talk about the fact that the persistent volume has a YAML file that we're going to actually define a persistent volume with. You see that here it says kind persistent volume, and it's available to pods who issue a claim. So it's a nice decoupling. That is, this persistent volume is available here on all pods on this VM host. And so that brings us to the next section here, the actual consumers of this volume. Here we have a pod, as you can see. It has a container, an Nginx container, and we want to basically consume this volume. And we do that by use of a claim. And so we're going to actually introduce the third of the YAMLs here to be a claim against the persistent volume. And so you see here the three pieces of YAML files working together to expose some storage, some physical storage on the VM host. And this is the relationship between all three of them. And so basically the pod has a volume that is attached to a claim, and the claim is around 3 gigabytes. Now, as mentioned before, this is really the diagram we ought to be thinking about. This is what all those YAML files are attempting to represent, whereby we have a network administrator really sharing the storage through a storage pool for which the developer lays a persistent volume claim against, allowing his pod, his applications inside the pod, to access this shared storage infrastructure. In our case, we're kind of cheating. We're putting everything directly on the VM host. Again, we're doing this just for demo purposes to really demonstrate how these YAML files work, but always keep in mind, really, this is the way it ought to be working. Here you can see the actual GitHub repo, K8s vols, where I have the source code, the volume, the persistent volume, the persistent volume claim, and then the pod itself, which consumes the storage. So this is all here for your review. I recommend you go through line by line and kind of understand the basic syntax here, and it is quite basic. So let's start here with the persistent volume itself first. You'll see here that I'm just creating these three files from scratch. The first one, of course, is persistent volume. You'll notice the kind says persistent volume there at the top, and then some of the other capacities like 10 gigabytes, etc. Again, recommend you go there. Let's go do the second one here, and this is the actual claim against that storage. And this is basically saying I want 3 gigabytes out of that 10 gigabytes of storage. The kind is persistent volume claim. And so here you can see the different parameters here that make up. It's requesting 3 gigabytes. And finally, the third YAML file here, this is the pod itself. This will define a volume that the Nginx container is going to use. And so you'll see the different sections here, and we kind of talked about the relationship. We got all three now. The next step is to actually go and do a kubectl create command to actually put these basic YAML files into use. Okay, notice we've got all three YAML files complete now. Let's go ahead and issue the kubectl command against the volume first. So -f, and then we'll go ahead and do that one. And then, of course, the claim is next here. So we'll just go up arrow and just fill in claim here as the next actual file, and that should succeed. And then finally the pod, and that really ties the three pieces together here that make up the different components for the shared volume for my Nginx container. So we'll do a couple quick commands here. Let's go ahead and do the first one to check the volume, and that's a kubectl command get pv for persistent volume, and then we'll say task pv volume. As you recall, that was the name of our persistent volume, and it's here. Let's now take a look at the command itself, the claim rather. So kubectl get pvc, the persistent volume claim, and that's the task pv claim name that we need to look up here. Let's see if that's in place. It is. And then finally the third one here is the pod itself. So that's another kubectl command here, get pod task pv -pod, and it looks like all three pieces are in place. Later we'll add in a service so it can come in, from the outside, but for the moment I think the next step, what we want to do is curl in to the agent once we remote into one of the two agents where this is all. Now one of the things we want to do next is figure out where that pod is running, which agent, because that's the one that we want to remote into and experiment with Nginx. So let's go see if we can issue that command you just saw here, which is essentially describe the pod, and that should tell you which agent's running on, and it looks like it's running on agent 0 over here. So if we basically say kubectl get nodes, you'll see that there is in fact a node 0. We talked about how we would remote into that earlier in this discussion, so let's go ahead and do that. Let's remote in and see from there inside of that running agent if we can essentially, and rather more than just the running agent, we're going to go into the container running in that image and do the curl command. We haven't yet exposed the IP address of that running pod, of that running container, so we're just going to remote directly into it. But first, let's figure out, let's review back how we would SSH into that. Essentially 2 steps, one going to the master and then to agent 0 there, as you see. So let's do that next. We've already copied the SSH key, so we don't need to do that again. Now it turns out we can just go directly to the pod without worrying about which host it's on. This will bring us to the right host, so we'll do the kubectl exec command, interactively connect into a bash folder here. We're in here as root, so I would say the next thing we want to do is do an apt get update. So apt get update, make sure we have the latest binaries here to do the install of curl, because after all, from within here we want to do a curl command against localhost to see that index page, and that's really the whole point of this whole exercise. So let's go ahead and install the curl package. It should be pretty quick here. Okay, that's complete now. Let's just basically clear the screen and finally from within this pod do the curl command and actually see what's going on here. Let's make sure curl is installed appropriately. We'll just do curl -- help to make sure it's in there. It is. So now let's just do curl localhost, and everything looks like it's working. Hello from Kubernetes storage. This has been successful. So Nginx has successfully leveraged that persistent volume of shared storage. So any pod actually running on both our agents has access to its local persistent storage. We notice that we create a pod, and using a claim we can get to that storage. And so this exercise is just about complete. Let's do a quick review. So this kind of wraps up this module. One of the last things we'll probably do in the next section, a quick video on how I would expose this pod as a service so that from the outside world we can get the same hello world. Again, just to review, we used a number of YAML files to leverage this persistent volume, this storage here, where we put an index.html file allowing our container, our Nginx container, to access the shared storage and actually show hello world. Now, we could have a number of pods all sharing this storage here, and really that's the point here, is to show how persistent volumes, pods, and persistent volume claims can be used together to leverage shared storage on a VM host.